Okay, everybody, this lesson is on formulas and applications with quadratic functions. We're going to start with solving some formulas. First one, solve for r. And our formula is a equals pi r squared. The first step in solving for r is to divide both sides by pi. Pi's cancel over here, and so I have r squared, and that will equal a over pi. Now the next step is to divide, or actually to take the square root of both sides. R squared equals a over pi. I'm going to take the square root of both sides. Don't forget the plus or minus sign here. And I end up with r equals plus or minus. Now this radical here, your book will most likely want you to rationalize it, rationalize the denominator. So I'm going to write that as square root a over square root pi. And in a previous chapter we learned that to rationalize the denominator here, we will multiply the numerator and the denominator by square root pi over square root pi, like that. R equals plus or minus the numerator here multiplied together is the square root of a pi over the denominator square root pi times square root pi is just pi. And we have our formula solved for r, just like that. Here's another one. Solve for v. And our formula is w equals k times f over v squared. Now the first thing I'm going to do here is eliminate the fractions, and I'm going to do that by multiplying both sides by the common denominator, which is v squared. These will then cancel, and I now have v squared times w equals kf. The next step is to divide both sides by w. Divide by w, divide by w. V squared equals k times f over w. Okay, now to get rid of the square on the v, I'm going to have to take the square root of both sides. Let's rewrite this here. Taking the square root of both sides, don't forget the plus or minus sign here. And we end up with, let's write it up here, v equals plus or minus. Now once again, just like the last problem, I'm going to split that into two radicals so that I can rationalize the denominator. So that's square root kf over square root w. To rationalize the denominator, I've got to multiply by square root w over square root w. V equals plus or minus the numerator multiplied together is the square root of k times f times w. Okay, good enough. That's a k in there. Over square root w times square root w is just w. And let me try to fix that one more time. There. And we have it solved for v. There it is, right there. Okay, here's another one. Solve for capital A. D equals the square root of 4a over pi. Now the first step on this one is to eliminate the square root, and in order to do that I will have to square both sides. Let me rewrite it here for you. Squaring both sides, like that. The left side is d squared. The right side, the square root and the square cancel away and leave you with 4a over pi. Now I'm trying to solve for a, so the next step will be to get rid of the fraction, multiply both sides by pi, times pi times pi. 4a equals pi times d squared. And last step in solving for a, we're going to divide both sides by 4. 4's cancel there then. And we have a equals pi d squared over 4. And our formula is solved for a. Here's one similar to that. Solve for little a. S equals 30 square root a over p. So just like the last problem, I will first square both sides. Square this side and square this entire side. On the left we have s squared. On the right side we must square everything in the parentheses. So I've got to square the 30, which is 900. 30 times 30 is 900. Times. Here the square root and the square will cancel each other away and leave you with a over p. Okay. The next step in solving for a is to eliminate the fraction. So I'm going to multiply both sides by p. Like that. P's will then cancel away. And I have p times s squared equals 900a. And one more step. Divide both sides by 900. And we have a equals p s squared divided by 900. Our formula is solved for a. There it is. Okay, very good. One more. Solve for t. S equals 2t squared plus k times t. Now notice here that I have a t and a t squared in the formula. It's a quadratic in terms of t's. And so I'm going to have to use the quadratic formula actually to solve this equation for t. To use the quadratic formula, To use that, I have to have it set equal to 0, so I'm going to move the s to the other side, like this. Now, see, this is a quadratic equation in t. It is similar to, in standard form, 0 equals ax squared plus bx plus c. The a is 2, the b is k, and c is negative s. And instead of x's, we have t's. So down here, I'm going to use the quadratic formula to solve this equation for t. T equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. T equals negative b, so that's going to be negative k plus or minus the square root of b squared, which is k squared here, minus 4. Our a is equal to 2, and our c here is negative s. And all of that is divided by 2a, which is 2 times 2. Okay, so I plugged in all of my numbers here, the 2, the k, and the negative s for a, b, and c. We can simplify a little bit. Negative k plus or minus the square root. Under this radical sign, I have k squared, and negative 4 times 2 times negative s is positive 8s, and that's all divided by 4. And that is basically it. We have actually two answers in solving this for t. It's t equals negative k with the plus sign, square root k squared plus 8s all over 4. And the other answer is t equals negative k with the minus sign, square root k squared plus 8s, it's a k there, all divided by 4. Both are solutions to the formula solved for t. And those are examples of solving formulas. All right, next in this section are some applications. This one is a rate, time, distance problem. It says in 4 hours, Joe's boat can go 15 miles upriver and come back. The speed of the current is 5 miles per hour. Find the speed of Joe's boat in still water. So we're going to let x equal, right here, the speed of Joe's boat in still water, what we're trying to find. All rate, time, distance problems can be solved with the help of a 6-box chart like this. Rate, time, distance. We have two things occurring here. We're going upriver and we're going downriver. Now, if you go upriver, the current will slow you down. So your boat is not going to be going x miles per hour. It's going to get slowed down by the speed of the current. In this case, you're going to go x minus 5, because 5 miles per hour is the current, which is slowing you down. If you go downstream, the current will push you, and so you're actually going faster than the speed x. You're going to be x plus the speed of the current, 5. So upstream is x minus 5, and downstream your rate, or your speed, is x plus 5. Now it says right here that you go 15 miles upriver, so the distance is 15. And you come back. Well, if you come back the way you went, the distance is the same. That's also a 15. Now to fill in the time, we don't use this 4 yet, because the 4 is actually the total time. The time here, if you look at the formula right up here and solve for t, time is equal to distance divided by rate. And so in here I have 15 distance over the rate x minus 5, and down here I have 15 divided by x plus 5. Those are the times going upstream and downstream. Now the problem says in 4 hours Joe's boat goes up river and comes back, and so total time is 4 hours. So I take this time that it takes to go upriver plus the time that it takes to go downriver, and that should equal a total time of 4 hours. That's the equation we need to solve here for x. Now in order to do that, to solve this equation for x, I have to multiply both sides by the common denominator. And in this case, the common denominator will be x plus 5, x minus 5. So I'm going to multiply both sides by that. Now I distribute this times this term. The x minus 5's cancel, and leaves you with 15 times x plus 5. Distributing over here, x plus 5's cancel, leaves you with 15 times x minus 5. And over here, if I multiply those together, I got 4 times x squared minus 25. I've eliminated all the fractions, but I still have to distribute again. 15x plus 75 plus 15x minus 75 equals 4x squared minus 100. Okay, we have a quadratic here. I see an x squared, and so I'm going to combine all my like terms, move everything over to the right side so that the equation is set equal to 0. So we have 0 equals 4x squared. 75's actually cancel away. Minus 30x minus 100. To make those numbers a little smaller, I could divide everything by 2. Divide by 2, and both sides actually. And I end up with 0 equals 2x squared minus 15x minus 50. Now, to solve this equation, I could either use the quadratic formula or I could see if it factors. Let's try it. I think it may factor. 2x squared has to be 2x times x. And factors of negative 50. Let's try negative 10 and positive 5, or maybe positive 10 and negative 5. If I put the plus 5 here and the minus 10 there, that will give me the correct factorization. Let's just double check that. That's 5x. That is negative 20x, and that does add up to the correct middle term, negative 15x. So it is factored correctly. Let me move this out of the way here. Okay. And so 2x plus 5 equals 0, or x minus 10 equals 0. This one gives me a solution of negative 5 halves, and this one gives me a solution of 10. Now, since our speed cannot be negative, I will rule this one out as an answer. The answer must be 10, and so the speed of Joe's boat up here is 10 miles per hour. And I have it solved. Okay. Moving on, next one. Bob can complete a lab test in 2 hours less time than Jane. If they can finish the job together in 2 hours, how long would it take each of them working alone? This is an example of a work problem. We saw some of these in a previous chapter. The work problems can be solved with 9 boxes, or with the help of 9 boxes anyway. Rate, time, and then distance or work here. And we have, on the side, we have Bob, Jane, and then both of them working together. Now, we want one job complete, and so all the amounts of work, or the distances, the way I think of them, are all ones right here. So we fill all those in as ones. The time it takes Bob, he can do it in 2 hours less time than Jane. So if I let x equal Jane's time, so I'll put an x there. If x is Jane's time, then Bob takes 2 hours less time. His time is x minus 2. They can finish the job together in 2 hours. So both of them working together takes a time of 2 hours. Now, rate is distance divided by time. And so the rate here is going to be distance 1 over x minus 2. This one is 1 over x, and this one is 1/2. So I'm just dividing this column by that column. Now, like all work problems, our equation here comes from this fact that this rate, Bob's rate, plus Jane's rate must be equal to their combined rate. And so our equation is 1 over x minus 2 plus 1 over x equals 1/2. That's the equation we need to solve. In order to do that, I have to eliminate the fractions by multiplying both sides by the common denominator. 2x, x minus 2 over here, and 2 times x minus 2 over here, common denominator. Distributing this times this, the x minus 2's cancel away and leaves you with 2x. Distributing over here, the x's cancel away and leaves you with 2x minus 2. And then on this side, just the 2's cancel and leaves you with x minus 2. Now, We distribute again and get 2x plus 2x minus 4 equals x squared minus 2x. Notice that this is a quadratic equation, and so I'm going to combine all my like terms and move everything to the right side here, and I end up with, putting it up here, 0 equals x squared minus 6x plus 4. Okay, so I have to solve that quadratic equation for x. Notice that it doesn't factor, so I'm going to have to solve it using the quadratic formula. Use the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c. Divide everything by 2a. b is negative 6, a is 1, and c is 4. Simplifying now, we have positive 6 plus or minus the square root of 36 minus 16 is 20, all over 2. Now I'm going to want a decimal approximation to this, so I'm not going to bother simplifying square root 20. I'm just going to split this into two parts. If I use the plus sign, I get 6 plus the square root of 20 over 2. And if I type that into my calculator, I can get a decimal approximation to that. And the calculator tells me that this is approximately 5.2. Or, if I use the minus sign, 6 minus square root 20 all over 2. 6 minus the square root of 20, divide by 2, I get about 0.8. So which one is the right answer, or are they both correct? Well, the problem with 0.8 is that if I go to the chart up here, if Jane's time is 0.8, then Bob's time is 0.8 minus 2, and that would be negative, and so that we can't have that. We can't have a negative time, and so 0.8 is no good. The answer must be 5.2. If I go up to the chart, Jane's time is 5.2 hours, and that makes Bob's time 2 hours less than that, which would be 3.2. And that will work. That makes sense, and so those are our answers. So we got Bob takes 3.2 hours, and Jane will take about 5.2 hours. And so we solved our work problem here with the help of the quadratic formula. Okay, let's look at another application now. Find the lengths of the sides of the right triangle round to the nearest tenth. Our right triangle has sides x, x plus 1, and x plus 4 there. All right, I forgot to write it in ahead of time. So I have to find x in order to find the sides of this right triangle. What we have to recall is the Pythagorean theorem. And the Pythagorean theorem says that if you have a right triangle with sides a, b, and hypotenuse c, then a squared plus b squared will equal c squared. And so if I use the Pythagorean theorem on our right triangle up here, I will get x squared plus x plus 1 squared should equal the hypotenuse, the longest side squared, x plus 4 squared. Okay, so I use the Pythagorean theorem to get that equation. I can now solve this for x. I got to multiply all of it out, though. This is x squared. X plus 1 squared, FOILed out properly, is x squared plus 2x plus 1. And x plus 4 squared is x squared plus 8x plus 16. Combine all my like terms. I'm going to move everything to the left side. And I notice these x squareds here cancel away. And I get x squared minus 6x and minus 15. Okay. So I end up with that quadratic equation, which I notice doesn't appear to factor. So I'm going to have to use, once again, the quadratic formula to solve this. X equals negative b plus or minus the square root of b squared minus 4 times a times c. And we'll divide the whole thing by 2a. Plug your numbers in. B is negative 6, a is 1, and c is negative 15. Simplifying, positive 6 plus or minus the square root of 36 plus 60 is 96, all over 2. Okay. Two possible answers here. If I use the plus sign, I get 6 plus the square root of 96 over 2. If I type that into my calculator to get a decimal approximation, after all it says up here, round to the nearest tenth, I get an answer of, let's see, approximately 7.9. If I use the minus sign instead, 6 minus the square root of 96 over 2, and if I type that into my calculator, I get approximately negative 1.9, approximately. Well, once again, you can't have a negative number for this word problem, for this application, because it represents the side of a triangle. So that answer is no good for our problem. It must be that x is about 7.9. If I go up to my triangle, this side is 7.9 approximately, which means that this side is one more than that, which is 8.9, and then this side up here is 7.9 plus 4, which would be 11.9. And so the three sides of our triangle are 7.9, 8.9, and 11.9. And we have our problem solved. Okay, next. A pool is 30 feet wide by 40 feet long. A border of uniform width around the pool has an area of 296 square inches. What is the width of the border? Okay, here's our pool. The pool is 30 feet by 40 feet. Now let's actually put those numbers inside here. 30 feet by 40 feet. We have a border or a walkway of uniform width going around it, like that. And we want to know the width of this border, and so I'll make that x there, this little distance, the width. So each of these is x in here. Okay, all those are x's. Okay, a border of uniform width around the pool has an area of 296 square inches. So this area in here, if I can fill it in here, we'll use red here. This area in here is 296 square inches. So what is the width of the border? Well, let's see if we can come up with an equation here. I notice first of all that the distance from here to here would be this 40 plus an x plus another x. So all the way across is 40 plus 2x. from here to here would be 30 plus 2x's. So the area of the large rectangle is the length times the width. The area of the whole thing is 40 plus 2x times 30 plus 2x, length times width. Area of the entire pool plus the border. The area of the pool in here is 40 times 30. Area of the pool is 40 times 30. Now, if I take the area of the entire rectangle and I subtract the area of the pool, I am left with the area of the border. I'm subtracting out the area of the pool to get the area of the border. And the area of the border is supposed to be 296. Okay, and so that gives me an equation that I can solve for x. In order to do that, I need to FOIL this out right here. So that's 1200 plus 80x plus 60x plus 4x squared minus 1200, and that should equal 296. Okay, so let's see. We have these canceling away, and combining our like terms, moving everything to the left side, we end up with 4x squared plus 140x minus 296 equals 0. Okay. I notice that everything is divisible by 4, so I can make these numbers a little smaller for me by dividing everything by 4, and I end up with x squared plus 35x minus 296 divided by 4 is 74, and that equals 0. Okay. Now let's see if that factors. If it doesn't, I'd have to use the quadratic formula again, but I do think it factors. It turns out that the two numbers that multiply to negative 74 but add up to 35 are going to be positive 37 and negative 2. So it does factor. And so this gives us x equals negative 37 or x equals 2. Now, once again, you can't have a negative length for this word problem, for this application, so I'm going to rule that negative answer out. Our answer must be x equals 2. And so I have the answer to our problem, the width of the border is 2 feet. And it's done. We have it solved. Okay, one last problem. A rocket is launched from ground level. Its distance in feet from the ground in t seconds is given by this function. At what time will the rocket be 550 feet from the ground? Okay, the 550 here is the distance. This is the d of t, the distance. And so I'm going to plug the 550 in here, which gives me 550 equals negative 16t squared plus 208t. I have to solve that equation for t. If I do that, it gives me the time at which the rocket is 550 feet off the ground. I'm going to move everything to the left side. which gives me this equation. And now I don't think that that equation will, it won't factor. I could divide everything by 2. That I could do and make the numbers a little smaller. 8t squared minus 104t equals, or plus actually, plus 275 equals 0. Oh, I forgot to divide that by 2 there. But I'm going to have to use the quadratic formula to solve this. Use the quadratic formula. So plugging everything in, negative b plus or minus the square root of b squared minus 4 times a times c. Divide everything by 2a. The b is negative 104, which goes there and there. The a is 8, and the c is 275. Okay, simplifying this, we get 104 plus or minus the square root. Let's see what's under the square root sign here. 104 squared minus 4 times 8 times 275 is 2016, all divided by 16. Now, I want I'm going to get a decimal approximation to this, so I'll just split it into 2 parts. If I use the plus sign, I can type that into my calculator. And I get an answer of about 9.3. And that would be time is 9.3 seconds. And so that's one answer to our problem. If I use the minus sign, I actually do get another answer here. I'm not going to cross this one out because it actually makes sense to our problem. This is 104 minus the square root of 2016 divided by 16, and I get about 3.7 seconds. And so these are my 2 answers. There are actually 2 times when the rocket is at a height of 550 feet. If you look at this function, we learned in a previous lesson that that is a parabola which opens downward because of the negative 16t squared there. It opens downward. And so it would look something like this if we sketched it. This is the t-axis and this is the distance axis. If this is 550 feet, then the rocket on its way up hits 550 feet at 3.7 seconds, but then on its way down it will also reach 550 feet again, and that must happen at the 9.3 seconds. And so we do have 2 answers to our problem. Both of them are correct. And that ends our lesson here on applications.